Okay, so in this video clip, I'm going to take you through a really fantastic resource that was developed in large part by Dieter Wirtz, but he did have a team, and there's some other additional names here as well: Tobias Assets, Johan Chalabi, and there's a few more names there. There's lots of people involved in this. The setting up of this Rmetrics organization, maybe to take a quick peek at what's there and some of the players and so on. But there's a series of different documents, PDF files, many available free for download. Some I think may have a charge, and you can just go in, take a look. You can download, it's free, and you can see who the contributors are here. And then you have different sections for time series, for looking at some of the statistical properties of stocks and so on. And there was a section here on options, Black-Scholes, and then even some portfolio theory. So this is quite, in each of the documents, you've quite an amount of material related to, in some instances, very specifically to options, so Asian option pricing with Rmetrics. And each of those documents are worth exploring in their own right. The bit I'm going to focus on is the bit related to option pricing. And basically, I have followed this hyperlink here. And what you have is you have a set of different R functions that are executable code, basically, that you can set up in RStudio, or in this instance in Colab, and then we can estimate, we can execute the code and then do some of the model pricing. And each of the models have been set out here. Each of the categories have been set out very cleanly, and I follow in tandem with what's available on the portal, and just do basic implementation. So just to see how that works then, let's say, for instance, we want to take a look at plain vanilla options. Now, the documentation for these, you can go into a few different portals, RDRR.io, and then take a look at some of the source code, and you can explore a little bit the pricing there. I think there's an embedded section here where you can load and code execute in the portal itself. But basically, if we take a look at how we might implement some of the code, and I'll just touch here on the plain vanilla options, which is basically Black-Scholes. Here we have a series of Black-Scholes, Black 1976 option pricing models. We also have the distribution. So we have bivariate distributions, and we have the cumulative normal distribution function and so on that we need for pricing, for implementing Black-Scholes. Much of the time here, when we run through, what we'll observe is some of this material is based on Espen Hoag's approach, and that's good because a lot of people in the options area are familiar with Espen Hoag. So you might take a look there at Espen Hoag. This book in particular is an option pricing formulas textbook set up for VBA. The approach in many instances here, the models are very similarly constructed to Espen's approach, and Espen then is referenced in the notes here included in the different sections of the function. So we have little notes narrating, okay, the implementation here follows Espen, right? And we see that a little bit as you go down through. So just to get a sense of how this might work and how you might use this resource, obviously it makes sense to go to the documentation, right, and take a look at the documentation. There's a lot of description, if you go into, if you download the entire document, you'll be able to track through the description of what's available in the PDF file, and in many cases it's free and serves a very useful function. Once we've got those functions, however, set up in or in Colab, right? All we basically have to do is to run or execute our code. We can load in our code, so we can use the magic R cell. So if you copy this snippet of code, and I'll leave a link to the Colab in our video below the video clip. So we would connect up to the server here, and normally a Colab is running Python code, but we can also run our code. So for instance, if we have these models for Black-Scholes and for the different distributions, the normal, cumulative, probability, and so on, estimation, I can execute that code. It runs, it's already executed, we can see there, and then I can go down to some worked examples. And I have some worked examples down here in the tabs for the Black-Scholes model. Again, this is following very closely Espen-Haug, and we can take the GBS function. So that's, if you like, if I come back here for a moment, we can see the GBSOption function is available here. So the GBSOption computes option price from the GBS formula, right? And that function, if we just come down a little bit, so the GBSOption, and then basically we have to pick, is it a call or a put? What's the stock price, the exercise, the maturity, the risk rate, the cost of carry, the annualized volatility of the asset's return, and then there's some description also incorporated in. So if we put in actual values then into the worked example, if I come down, and we'll take the values suggested by Espen-Haug, and in section 111, now I think this might be, there's 2 additions to Haug. I think this may be the first edition, but if I execute that code by saying, look, it's a call option, it's the Black-Scholes model, it's a call option, stock price 60, exercise 65, maturity is 3 months, risk rate 8, cost of carry 8, so no dividend. Remember, B is equal to the risk-free rate negative the dividend yield, and then the volatility sigma is 30%. We get an option value of 213, right? And below I put in my own figures, figures that I use over again just to test these models, where the stock price is 100, the exercise is 100, the time period is 1 year, maturity before expiry or expiration, risk rate 5%, no dividend yield, sigma 20, we get 1045, right? And then if I said, look, I'm looking for a put option, we could just change that to P, and we can execute that code, GBSOption function. It'll print out the parameters, the option price, it's a Black-Scholes option valuation, and it's giving us a date. It's now August 24th, and it's probably 1447, so 347. So we're basically the timing there is out 1 hour, so maybe it's without summertime being incorporated in, not sure. Okay, so we can run some code. We can put in, again, GBS function and set out the range of values we have here. There is a cash dividend, and that produces an option price, and it's for a call. Okay, so I've done that for a few of them. Basically, now if I wanted, for instance, to run estimations in the binomial model, I just go to the section here, Cox, Ross, Rubenstein, Jar-Rod, the Tian models are available here. If I run the snippet of code, and we must prefix the percentage R here before, if we're using the magic R cell. So if I execute this to run the R code in Google Colab, I must include this in the cell right? And if I don't, then the function doesn't work. So to run the binomial model, I load in the functions, and we have functions here related to Cox-Ross-Rubinstein. We've a binomial tree for Jarrah-Rudd. We've a binomial tree for Tian. And then I can go down to a worked example for the binomial tree. And you can see here, if I put in the values I had before and set n, the number of steps for the Cox-Ross-Rubinstein tree to be 100, I'll get a value close to 1045, right? Probably 1043 for the call option. And I could increase the accuracy here to, if I go to 1,000 steps in the tree and run again, I'll get close to 1045, right? So 1044, 8, and so on. If we raise that to 2,000, which is not an insignificant, it's not a trivial estimation. It's actually quite a large scale estimation. It's quite fast. 1044, 9. What about if I raise 3,000 steps in the tree? I should be close to 1045. Already close to 1045. By increasing the number of steps, of course, it's going to take longer. 1044.99. Okay, so you can see we're getting convergence here, and the values look basically correct. So I've no quibbles. The code is working. Now, if I go to the American options here, now if I don't, I haven't executed the functions here. So if I come down to the work functions, the worked example for the American option, or the American approximations, if I execute this code, it shouldn't execute because I didn't load in the function. So if I want to implement the American options, I must, first of all, come back here to the basic American option functions, execute them, and then when I go down to the worked examples, right, and now execute, it should work without too much difficulty, and it does. Okay, so in order for you to use any of these functions here, you need to work through, you need to execute the function first. A simpler way, of course, could be, I mean, you could just load in the entire package into R, into the Google Colab. So for instance, if you install packages fOPTIONs, then for instance, you should be able to run. So for instance, if I go into RStudio, we'll create a new instance. And that's loading up. And we'll bring across. Right, and we can say, I'm going to look at packages. And if I don't already have fOPTION, so fOPTIONs, right, I've already installed, but if I was installing this for the first time, I would just put in FOP. I would just hit install and it would install, right? So for instance, if I wanted to value our models here, we could do it not in the Google Colab. I could install fOPTIONs and then say, look, we need to make it available here in this environment. So if I double click here, it's loading in fOPTIONs. So we have library fOPTIONs, and all these packages then are available. And then, for instance, if I go back to Colab for a moment, and I take one of our worked functions, let's take the plain vanilla, GBS, copy, and go into RStudio. And just paste in Control V, and then execute that. you can see I get the value. So the GBS function is available, and that may be for some people a more desirable approach here, that rather than use Colab and look at the functions and the code and so on directly, look at the native code. You may prefer actually to use this approach. So for instance, if I wanted to run the binomial models, we'll just take the example that I'd given here. With minimum fuss, I can call up that function for Cox-Ross-Rubinstein in RStudio. Paste in the function. So it's an American call, stock price 100, exercise 100, 1 year maturity, risk-free rate 5%, cost of carry 5%, sigma 0.2, and we'll go up to 1,000 steps. And if I execute that code, we should get 1044.99. 1040, in fact, 1044.85. I think when we went to 3,000 steps, it was 1044.99. And it's taking a little while, but it is using the processor on this computer, and we're getting 1044.99. So that might actually, for a lot of people, be the best approach when implementing fOPTIONs and fBasics and the Rmetric packages. We can take a look at the package here, and we can come down, take a look at the actual code. So for the Black-Scholes option pricing model, you can see here there's a number of examples provided. So for instance, and there's some detail here also explaining what's going on. And normally if you come down towards the end here, we can pick out a function and just copy and paste in, and we can run. So we'll just put a £sign in front of the options and then GBSOptions with those parameter inputs. And you can see we get an output, we get a result, right? And that tallies with Hogue section 1.2.3 from Espen Hogue's textbook, right? I have a slight preference for setting it up in the Colab. Really, why is that the case? It's just simply, again, it depends on what you want to do, but sometimes you would like to see what's in the function. You know, how is the function put together? What type of assumptions are being made? And it's no harm to take a look at the native code. But if you're familiar with the functions already, and you're familiar with the, you know, the estimation properties, and you don't want to bother with this, then of course RStudio streamlines the whole process. Sometimes you don't want to see the native code, you just want the result, and then RStudio, obviously that approach makes a lot of sense. Another way you could go about this is just install package. So install dot package, open brackets, inverted commas, fOPTIONs, close off the bracket, and then go library, name of the package, and you can pull out the code. You can implement the code then directly, right? So you don't have to look at each of the functions here, right? It may be more feasible for individuals just to load the package into the R environment, and then, you know, not bother with, if you like, what is the gamma functions, what are this Asian option functions. Just as we have down here, run the estimation, right, with just a simple instruction, and all you've got to do is install .packages, name of the package, fOPTIONs, and then library, and then execute, and it'll work seamlessly also in the Google Colab environment. And that's one of the attractions as well. You can install our packages in Colab and run there very efficiently. in the Colab environment, and then you can share. If you wanted to share your work with somebody, collaborator, you can say, look, I can offer different status, offer editorial status, or just viewer status. Typically, when I'm sharing video clips, below the video clip, I leave the a link with the viewer status. But that means anybody can open up, look at, save down to their own Google Drive, make changes, pass back to collaborators. And it's a very useful way of approaching any form of estimation if you're working in a group and you're collaborating. Okay, so I think I've explained, maybe before I finish, just to say I've left in another couple of worked examples. There is some fOPTIONs, again, based on Rmetrics, and I've loaded in some code there for that. And there's some worked examples. Also, I've left links to other R packages that are doing very similar things. For instance, in the EPFIN, in the original fOPTIONs, I didn't see a trinomial function, a trinomial lattice. This one is available here from this contributor. I think it's Philippe, and you know, it's basically he follows the Rmetrics approach here for pricing the option. I'll get the name of that contributor. It's Patrick Enaf, University Paris 1. And he's a section here on, so for bonds, but also for options. And I just copied this function. Again, it's following very closely Rmetrics. I think he's a contributor to Rmetrics. I just loaded that function in. If we execute that, then, and I put in values then for the trinomial model, for in this case, it's a European call, I can get an output. Let's say if I change that to A, it's for the, now it's for the American call, it's the trinomial model, and I get a value of, for the trinomial model, the value of the American call, the delta, and the gamma, and we can raise that up to 1,000 steps, and so on. So you might take a look at these other packages I've discussed before. Derived markets, that's a really powerful package in for R, and I have some video clips there relating to derived markets package, R package. It's really good. You can take a look as well there. There's a lot of source code, very, very useful source code, and for bond valuation and so on, for duration, for pricing, for convexity, for the yield to maturity, right? So lots of very interesting R code that would be useful to people involved in fixed income, option pricing, and so on. So take a look, and I'll leave a link to the Colab underneath the video clip. Okay, I'll stop there.